Hello, fifth graders. We have been learning where water comes from. And today, what we're going to focus on is how we get that water out of the ground and to our houses so that we can use it for drinking water or for growing food in our garden or for feeding our animals. So today's lesson is called Engineering a Water Pump. So now that we know where our water comes from, let's take a look at how humans access these water sources. How do you think humans can get groundwater to the surface of the earth? And if the water is really deep under the surface, how can we get it? Well, some of you might be thinking about wells and how we can dig underground to get to the groundwater. And so if we dug deep enough, we could do that. And that definitely is a way. But then once you get down to that water, you have to have a way to bring it up to the surface. And the way we accomplish that is by using water pumps. So if we were at Pinewood, you would have an engineering challenge where I would give you some materials and I would give you the challenge of designing a water pump that will move 50 milliliters of water from the floor, and the floor would signify under the ground, up to the table, which would be to the surface of the earth. Because we're not together in school, I'm going to show you the materials and explain how you do this, and I'm going to have you make a plan, draw a diagram. So these are the materials you would have. 2 beakers. One of these beakers would go on the floor, one would go up on the table. The one on the floor would have water in it. This is a graduated cylinder, so you can measure how much water you're able to move. This is plastic tubing, and there are 5 of them. They're 1 foot long, each of them. And you would connect these together somehow to form a water pump. This is a syringe, and the way a syringe works is if you pull this part of the syringe out, then it can fill up with water. This is a 3-valve switch, and water can run through the valve. These are connectors that you can use to connect things together, and water also will go through those. So you would use these materials, plus I would have given you masking tape, paper clips, and rubber bands, and you would have tried to build something that would move the water from the ground up onto your table. Let me show you a video that will explain the directions a little better. Today we're going to do an engineering project, and so I'm going to show you what we would do if you were in school. We would be building a water pump, and our challenge would be to move water from underground. And so in my model, I put 100 milliliters of water down here under the ground, and we want to build something that's going to move it up into this beaker. Once you finish building it and testing it, we pour the water into our graduated cylinder. And the goal is to move at least 50 milliliters. There's 100 milliliters. So if you're super successful, maybe you'll move more than 50. But the goal is to move at least 50 milliliters of water from that bottom beaker to this top beaker. The material that you would be given 1 foot lengths of plastic tubing. You would be given 4 connectors. You would be given a 3-way valve, and so you could attach one of the tubes here, one over here, one up here. Water runs through this whole thing, and it has a change with where the water's going. You would get a syringe, and you would get as many rubber bands, paper clips, and tape as you like, and you can put into the plastic tubing, and then you can connect it, and now water will flow through this whole thing. So I just made a 1 foot length of plastic tubing into 2 feet, and the water will go through that. So what you're going to do is, I know you don't have these materials at home. I don't expect you to build this. What I'd like you to do is to draw a diagram of what your invention or idea is to use these materials and to move the water from the bottom beaker to the top beaker. So you're going to draw a detailed diagram. You're going to draw a table. You're going to draw a beaker down with the water and a beaker at the top of the table. And then you're going to draw some kind of system that would move the water from the bottom to the top. couple of constraints. You can't just pick this up and pour it. And you can't just take this syringe and scoop up the water and squirt it up here. It has to be some kind of system of tubing that would get the water from under the ground up to the surface, which is what this model is trying to show. So you're going to draw a picture, label everything. I'm going to show you the materials again, but you will work on that. That's going to be your engineering challenge. Okay, so now at this point, you need to get a piece of paper and a pencil, and you're going to draw the table. You're going to draw the beaker, one beaker on top, one beaker on the bottom, on the floor with water, and then you're going to come up with your own design. And you can label these plastic tubing. You can label this syringe, syringe. You can label this three-way valve, and you can label these connectors, or somehow indicate what the different parts of your diagram are. So you're going to draw a picture of what you would love to build if I could get these materials to you, of how you would move the water from one beaker to the other. So press pause, draw your design, and then press play and come back to this video. All right, welcome back. I think you guys have finished drawing your design. And so now I'm going to show you what I made. Now, with engineering challenges, there is not one right answer. There could be many solutions to this problem. So your diagram might look like my video, or it might look different. And I am going to ask you to send me your diagrams if you want me to build your model and test it out. And I'll collect those all the way until Friday. And then next Monday, I'll post more videos. But this is the model that I came up with. All right, hi guys. So I hope you drew a diagram of how you thought to engineer this. This is just my idea. I wish that you guys were with me and you could build your own, because I know you would come up with great ideas. They don't give me an answer key. So the way that I solved this engineering problem is I took 1, 2, 3 pieces of plastic tubing, and I used 2 connectors to connect them. And then I used the three-way valve, and I connected it to my syringe. And then I took another connector and connected it to the water pump. To this plastic water tubing to create a water pump. I didn't use the rubber bands, the masking tape, the paper clips at all, and I also had a couple pieces left over. So there are obviously other ways to do this. This is how I did it. So what I have to do is I have to have this turned this way so that it'll create a suction to pull this up. And I pull up on my syringe, and I don't know if you guys can see on the video that it's filling with water. So I pull it up. And then I have to, and it took me a while to figure this out, how to use the three-way valve. But if I turn this, now this part is closed off. Maybe that's what you need tape and rubber bands for, because it falls apart. There you go. And now if I push this out, you can see the water going through. And there's some water there. And then I can change it back, pull it up again, because the goal, remember, was to get 50 milliliters. I don't know if I have quite 50 milliliters. Oh, it's getting really hard to pull. All right, I turn it, and then I push the water back out again. And then, in order to test to see if I met the criteria, I'm going to pour it into my graduated cylinder. And, oh, I did way more than 50. I pulled up almost 85, just under that, looks like 83 milliliters of water using my water pump. Now, this was my idea. If you guys drew a different diagram and you want to send it to me, I can try to build this and make a video to show you what yours would look like and see if it would work. This one did work, but I know there's a lot of other ideas out there. All right. Okay, so that was my water pump. But if your diagram looked different and you want to try it out, you can email it to me and I will try that out. Now, there's a chapter in our book that we would read to go along with this lesson that talks about how people get groundwater out of the ground and how they move it from place to place. And it's called Pipes, Pumps, and Paces. So I'm going to read that to you. Reading 5, Pipes, Pumps, and Paces. People run into problems related to all aspects of life. When faced with a problem, you must try to solve it. There appears to be a lot of water in the world, but there are problems. How much of the water can we actually use? And where is the water we can use located? How do people solve these problems? It turns out people have been engineering solutions for ages. Back in the 1st century, the people of the Roman Empire needed to move clean water into their cities from far away. The river water was not as clean as water from natural springs. The Romans built systems for moving spring water called aqueducts. Most of the water went through underground tunnels. There were some obstacles over the distance of 50 or more kilometers, that's about 30 or more miles, that the water needed to travel. Water moves down a slope by gravity. How do people move it across low valleys and deep canyons? Today, we can still see some of the high bridges people built to move water. You may not see the downward slope of a bridge like the one shown here. The bridge slopes by just 2.5 centimeters, that's 1 inch. The whole aqueduct drops by 17 meters from one end to the other. So the Romans built this bridge called an aqueduct, and if you look at it closely, it slopes a tiny bit, just enough to keep the water moving by the force of gravity. The Romans built the bridges out of rock and built the pipes out of lead. The materials were natural, not advanced. Most water went to the public fountains and baths. Few homes had water going straight into them. And that's because that was a really long time ago. But today, developed countries have much larger networks of pipes that get water into individual homes. Using pipes is nothing new, but the materials used to make them have changed over time. The lead that the Romans used dominated for a long time. Minerals in the water coated the pipes, so flowing water did not touch the lead. Today, there are health risks caused by lead pipes because minerals are removed and water sits in the pipe longer. The Romans didn't turn off the water as much as we do. Now, metal pipes such as steel, iron, and copper are part of our water systems. Plastic has become a suitable material too. You may see pipes like these around your home. Fun fact, buildings have pipes in many shapes and sizes. Look around your home with an adult and see what kind of pipe you can find. Oh, we have those in Rotterdam. You guys have seen those water towers. Water towers store clean water before it goes to homes, schools, or offices. Pipes bring surface water into homes in big cities and towns. First, water goes through a treatment plant to make it ready to drink. Treated water has chemicals added to it. The chemicals separate out dirt and kill bacteria. The water leaves the plant through pipes that go to homes in the city water network. A home outside the city in a more rural spot still has pipes, but gets the water that flows through the pipes from a different source. The water gets pumped up from the ground through a well. Some pumps are outside of the well and pull water up like drinking from a straw. Other pumps are down inside the well and push the water up. The pumped water goes into a storage tank, so the pump doesn't have to run all the time. Remember, groundwater is protected from surface pollution, so it doesn't need extra chemicals to treat it. The drawback to private wells is that they can go dry from too much pumping and not enough rain or snow melt to replace the pumped water. In some parts of the world, it is not too hard to get water into individual homes. Some regions don't have as much water as others. How can people get water to places where there is less of it? The 1st century was not the only time people have needed to build aqueducts to move water to where it is needed. The United States made the effort more recently. Hardly anyone lived in California's Imperial Valley before canals started to bring water there. The Imperial Canal brought water to the valley, but went through Mexico. The United States wanted to build a canal that didn't cross the border. The All-American Canal diverted water from the Colorado River over to the barren land of the Imperial Valley. The canal is the only source of water for the cities that began to grow in the valley. The canal was working to achieve its goal, but had a big problem. Not all of the water was making it to the end of the journey. A section of the canal went through sand dunes and lost water when it seeped into the sand. People built a new section of the canal lined with concrete between 2006 and 2009 that fixed the problem. So here we see some pictures. This canal was lined with concrete to solve a leaking problem. Money is needed to build roads that connect cities or towns. Modern water networks and the ones of the past have one need in common: money to build them. The Roman Empire had money from conquering other nations. Money is important to build systems like roads and aqueducts that keep a nation together and growing. Infrastructure is all the resources that make taking a bath, going to school, or traveling somewhere possible. The way of life is much different in countries that are less developed. Women carry water back to their homes in this picture. In 2015, the World Health Organization estimated that 600 million people don't have treated drinking water. Villages in poorer countries do not have pipes bringing clean water into their homes. Every day, people have to bring containers to the nearest water source, fill them up, and walk the water back home. They usually have to make the trip more than once a day, so they walk several kilometers or miles in just one day while carrying water that is very heavy. About 20 liters of water, 5 gallons, weighs about 18 kilograms or 40 pounds. There is time for little else in a day. So why do people walk for water? The governments face problems getting water out to villages because there are no paved roads. Resources are limited, and a lot of villages are isolated. The people lack money to move and set up a new home. Plus, there are dangers to living too close to the water. The main risk is that floods can damage the land and crops that people grow. The walking takes hours and is physically tough on people's bodies, but the risk of losing resources to floods outweighs the labor of collecting water. When countries do not have the infrastructure to meet the needs of the people, other nations provide extra help. Special organizations raise money and send workers to struggling countries. You might have heard of the Red Cross or UNICEF, the United Nations International Children's Emergency Fund. Workers dig wells, build pumps, and build systems to manage waste. These efforts are helping improve the lives of people around the world, but the work is far from done. And that brings us to chapter 6, so we're all done. So I hope you learned a lot about how we get water out of the ground today and how people move water from place to place and where our water is actually coming from. There's nothing to turn in today. If you want me to try and build and test your water pump design, email it to me by this Friday. I will make videos of the different designs and post them next Monday. You are done with this lesson, so you can mark this as done if you would like by just clicking on where it says Alicia Sherman posted a new assignment. It will open to another page, and there's a spot where you can click mark as done, and you can do that because you are finished. All right, have a great day, and I will see you guys on Wednesday.